So 5.1 to 5.3, review. Okay, now 5.1 and 5.2 were the number lines where we actually did the problems algebraically. Okay, 5.3 was when we started looking at the pictures. So we're going to start with the algebra example, and then we're going to go back and we'll do a final review with the pictures. Okay, so here we go. We're going to say f of x equals x cubed minus 24x squared minus 51x. All right. Now, there is no question with this right now. All we're going to do is we're going to make both the f prime and the double prime number line, and then we're just going to make all the conclusions possible. All right. So, let's do, okay, f prime of x. So I'm going to start with the derivative. And I'm going to start by finding the zeros of the derivative, right? Because I'm going to make the number line. Okay, so I'm going to factor. And I'm going to get my 2 zeros. All of this is f prime. I'm going to make the f prime number line because we have the fun chart. We've got the basic ideas on how to use it. All right. F prime number line. Right? If you're making an f prime number line, you have to use the derivative stuff to fill it out. So I'm going to start with those two numbers, right? -1 and 17. And then I'm going to figure out my positives and negatives by plugging in. I guess we'll start with like -2, 0, 18. Now, does it matter where you plug in? No, as long as you're plugging into the f prime. So I'm going to plug into the factored version because I feel like that's easier. Okay, so I get a positive. Obviously, I've got zeros right there because that's what I was finding. I'm going to plug in 0. Negative. Okay, and I'll let you do the third section. Okay, so I get positive. All right, I'm going to switch colors because I'm going to do my fun chart, all right? Now, f of x, that's the original. If this is the f prime number line, it tells me that the original, I'm looking at the board because the chart's up there, is increasing or decreasing. So positive means that the original, that's why I'm doing it in a different color because I'm drawing what f of x is supposed to look like based on what the number line tells me. Then it has a 0 slope. Then it's decreasing because the tangent slopes are negative. And then it's a horizontal, and then it goes back up. That's what f of x looks like. It's increasing, then decreasing, then increasing. F prime tells you about maxes and mins. So you can still look at the chart, which is over there, right? Right? F prime, the pluses and minuses, is the number line. So it's either going to tell me maxes or mins based on how the number line is changing. All right, so that means that at x equals -1, f of x has a max. I'm using a different color so you can tell that I'm talking about f of x here. This is an f prime number line, and I'm talking about f of x. At x equals 17, there's a minimum. You have to label your number lines. You have to. Because all the work is going to look the same. But depending upon which number line it is, it's going to tell you different things. Okay. Do the second derivative number line. So I'm just going to go back to what f prime is, and I'm going to do the second derivative. Right? F to f prime, and then f prime to double prime. I'm going to do the same thing, set it to 0, solve it, make the number line. I am going to leave a little space above the second derivative number line, just because I want to do more f of x drawing. Okay. Second derivative number line. And so I got x equals 8. All right. Do your pluses and minuses. So second derivative, right? Double prime number line, which means you have to plug in to the second derivative. So I'm going to plug in from this line. So I get negative. I get positive. All right. Now, on the fun chart here, I erased this part because that's not the part I'm looking at right now. I have the second derivative, pluses and minuses. I still just want to know what f of x is doing. So I'm going to go back up to the concavity. So the second derivative explains the concavity of f of x. So it's concave down, point, concave up. Oh, so looking at this, I can see where it's concave down, and I can see where the original graph is concave up, and it tells me that at x equals 8, that's where the point of inflection is. This is where the concavity changes. Notice that I didn't do anything with that middle row of the fun chart because that's not what I was looking for. I was just looking for maxes and mins and points of inflection. All right. Oh wait, I still see a lot of writing, so I'll wait. Okay, when you do this worksheet, notice that we're looking for f prime, mins and maxes, double prime, inflection points, and the graph. all the answer choices are right here, okay? When it says graph, it means what does f of x look like? Well, notice these two pink pictures. That should give you enough information on what f of x looks like to make a choice. You have to do the work for this on paper unless you write really small. Otherwise, it's not going to fit and it's going to get really messy, right? See, it's not a lot of work. It's a little bit of derivatives and some factoring and the number line, okay? So that's what I expect to see for this side of the worksheet, okay? I'm going to do the picture examples, right? The back side has a picture on it. We're going to do the picture example here so you know what it's supposed to look like when you move on to your worksheet today, okay? So turn this worksheet over, and we're just going to do a little bit of labeling here, and then we're going to go back to our notes and actually do the example. Notice here that this says the graph of f of x. That means you're literally just looking at it. I suggest you try to find the point of inflection and put a little open circle on it, okay? The one thing that I'm going to tell you is that concavity comes in half shapes. So this is both concave up. This is both concave down. So as I'm looking at this, concave up, concave up, concave up, concave down. Now your answers are all integers. So pick the nearest integer coordinate. Right, so I'm just, like those open circles you saw in Delta Math for points of inflection, you have to look for them so that when you're looking to answer it, right, see your answers are all down here, they're all integer values. So whatever point you think you're looking at, pick the nearest integer. So concave down and then concave up. So you're just looking for those points of inflection. All right. I want you to look for the points of inflection on this graph. Little trickier, but nearest integer. Notice that these are counting by twos, so I might suggest that you add a couple tick marks here so that you can count by ones. All right, see if you can find the points of inflection. Nearest integer. So you're looking for where concave up and down is switching. Okay. Where is my concavity switching? Well, I definitely see concave up here. And it definitely looks like concave down here. So somewhere right in there is where the concavity is changing, okay? And if I look at my answer choices, it looks like I have to go between -1, -2, and -3. So pick the closest one. It looks like -3 is the only spot out of those choices. Like 4 wasn't a choice, okay? 4 wasn't an answer choice, so I'm going to go with the next best one, and that was -3. Okay, so I can definitely see concave down, and then as I get towards the end of the graph, I can see the concave up. So where's that steepest slope? Where's the biggest slope? Somewhere in that circle there. Okay, so you have to pick the nearest integer because all of the answers are integers. Okay, so there's those points of inflection. Now you should be able to answer the rest of those questions. We're going to put the derivative graph in our notes, and we're going to look at how to create our number line so that we can answer all the questions from there. Okay, so that's where your stickers are from.
Oh, hi, I have a computer for Carolyn. Kara's not here.
Kara's not here.
Okay, thank you.
Again. Sorry. Okay. Here you go. So everybody should have stickers at their desk. We're going to do 2 examples. Okay. I'm just going to flip my page because I wrote really big. Each column is the same picture, so I'm going to go with the graph on the left first. And I'm just going to put it in my notes. Right? And then the second example will be the graph on the right. So there should be enough for 3 people on each sheet. So take yours and pass it if you need to. All right. Okay, so if you're looking at your paper, it's the one that's on the left. It has like a bounce in it. The other ones just go up and down. This one's got this little bounce in the middle. They're all the same. 2 columns. All right, so we're going to put a label up here. Change this label to F prime. So this is the F prime graph. It is a lot of thinking. All right? You can do it. You can do it. F prime. The F prime graph is going to match the F prime number line. Which means you're like plugging into the F prime graph. And so when I do the F prime number line, it's important to note the labels are matching. 1, 2, 3. I see 3 zeros on the F prime graph. That's a -8. Okay, so I got a -8, a 1, and a 7. I'm going to just change my spacing a little bit. Okay. Those are the places where F prime is 0. I have to fill in positives and negatives. Above is where you get positive values, right? What if you're going to evaluate, right? Kind of like we just did. What if you find x equals -9? That's right here. Is it positive or negative right here? Negative. Okay, so I'm going to put a negative. It's very similar to the algebra, but I'm reading the graph instead. Okay, so let's try like x equals 0. Okay, right here. Is it positive or negative right there? Yes. Okay, notice it's positive on the top half. So go x equals 3. It's positive. Okay, and then right here, it's negative. So now that I have the number line, it's easier to interpret once you have the number line because that's very similar. Okay, it's hard to look at the picture and say something about f of x. All right, so let's say something about, I'm just going to write below, is negative. Okay. Okay, look at my label. I want to draw what f of x looks like. Decreasing 0, increasing 0, increasing 0, decreasing. That's what it looks like. Decreasing, 0 slope, increasing, 0, increasing, 0, decreasing. That's what f of x would look like. just based on the fun chart. I'm just putting the columns together. Okay, so x equals -8 is a minimum because it's the bottom of the valley. Nothing happens at x equals 1 because it's just like a double increase. And then x equals 7 is where the maximum occurs, because f prime goes positive to negative. Okay. I was looking at an f prime graph, so I made the f prime number line. Positive above, negative below. All right. We're going to make one more number line. Leave some space above it, okay? Double prime. Okay. How do you get from f prime to double prime? You do the derivative, okay? But visually, that's the tangent slope. So if you want to get from f prime to f double prime, you have to look at the tangent slope. Okay, so this is tangent slope of f prime. That's what I'm going to look at. How do you go down a level? You do the derivative. The derivative is the tangent slope. So if I want to go from f prime down to a double prime, I have to look at the tangent slope. Like if you can think of an Etch-a-Sketch, like just erase it and then do the double derivative, because it's hard to think of all of these things simultaneously. So Etch-a-Sketch, second derivative. From f prime to double prime, I have to look at the tangent slope. Okay, I'm looking at the tangent slopes. That's where the tangent slopes are positive. So I'm going to label that tangent slope positive. Tangent slope positive in those two spots. Now, see those horizontal tangent lines I drew? Those are zero slopes. Those are important for a second derivative number line. -6, -2. Oh, missed one. Whew, so many. Okay. 1 and 4. Okay, well, I didn't space these out very well. I'm going to try again. Just in case I'm trying to correspond to my number line up here. -6. -2, 1, 4. Okay, that's good. Those are all my horizontal tangents. Positive tangent slope. Positive 0. Positive 0. Negative 0. Positive 0. Negative. Make this one darker. Right? Horizontal tangents, 0, 0, 0, 0. Positive tangent slope. Right. Pink marker. What does f of x look like? Okay, my fun chart. The second derivative, pluses and minuses. Tell me about concavity on the original. Okay, so I have concave up, concave up. When I have a double concave up, I'm just going to draw it nice and big over both sections. Okay, concave up, little concave down, then concave up, then concave down. those points were to show me points of inflection because the concavity was changing. All right, so x equals -2, 1, and 4 are where the points of inflection are. Now notice that was f of x I was answering about. Okay. Okay, exact same thing, okay? This is f prime. So make the prime number line, then make the double prime. So this is the second column, right? There's only 2 graphs. Each column was the same picture, okay? I'm going to fill it out. Tangent slope of f prime. All right. I'm going to let you try. What is that? Max. Okay. See if you can do either one of those number lines. Yeah. You know what? Let's just sing. Yes. Okay. See what you can fill out, right? See where your questions arise. And then I'll go through it again. This is our last example, and then you guys are going to use that worksheet for your classwork today. So every time, see how the label, which means you literally just read the graph. So, right, to go down a level, that's when you will understand. Yes, okay. Here's the, right, if you have empty papers, I'll take those. Oh. Like, for example, with like, if you still have drafts left, I'll grab that -8 here that we have it.
Yeah, but it's like, but that is positive. Oh, it's just 0. Okay. Okay.
Okay, here we go. So, -7, -2, 2, 7. I'll make my number line longer. Okay. Positive, negative, positive, negative, positive. 1, 2, 3, 4. Right? So if you got the graph, you literally just read it off the graph, where above is positive. Hard to read today. There you go, that's a little better. Okay, and below is negative. Okay, without the above. Okay. What does f of x look like? It goes up, 0, down, 0, up, 0, down, 0, up. Whew, all right, I can see it. Sure makes analysis easier when you're looking at it. Negative 7 and 2 are the maxes. X equals negative 2 and 7 are the mins. Okay. Tangent slopes, right? To go down a derivative level, you look at the tangent slopes. Right? I'm only highlighting half of them because it'll get too colorful if I highlight everything. So negative 4, 1, and 3. That's where the tangent slopes are 0. And it's negative, positive, negative, positive. The second derivative tells me about curvature. So down, dot, up, dot, down, dot, up. Okay, x equals negative 4, 1, and 3 are the points of inflection. Okay.